On behalf of the IBM Corporation, I'm pleased to present Cuthbert Daniel, Distinguished Statistician, to be interviewed today by J. Stuart Hunter, founding editor of Technometrics and recent recipient of the Deming Medal. Most appropriately, Stu has been a friend of Cuthbert's for the past 40 years. It's all yours, Stu.
Well, I'm here to be the interviewer of the American Statistical Association Distinguished Statistician Videotape Series. And I'm here to interview Cuthbert Daniel. Cuthbert's very, very hard to introduce. I first met Cuthbert as a graduate student many, many years ago. But first, to give some of his pedigree, he's the author of two very important books in the applications of statistics, particularly the industrial application of statistics. His book with Fred Wood on fitting equations to data is perhaps as frequently quoted as any book we can name with respect to that serious problem. And then his second book on the applications of statistics to industrial experimentation. There's the real Cuthbert Daniel coming out. The sage advice, the deep experience, his effort to communicate to the engineer. He's also, of course, very well known for his published works in the technical literature, most particularly his work on the fractional factorial designs, parallel fractions, his work with Frank Wilcoxon earlier on trend-free analysis using factorial designs. Cuthbert has been in the field applying theory in a resourceful way for his entire lifetime. He is really a statistician. He's not a mathematical statistician. He's not just a statistical consultant. He stands with both legs in both fields as a theoretician, helping to forward theory, helping to forward practice, and most important of all, to communicate to the rest of us. So Cuthbert, it really is a pleasure to see you once again. I can recall way back in Raleigh, North Carolina, back in the early 1950s when you came down to, actually I recall you're lecturing on half-normal plots. That's a long time ago, before that material was even published. And so we've known you for a long time. When I became, my very first consulting job was with you. Do you remember that?
No.
You asked me to come up to U.S. Steel. This is before I had my PhD, to give a seminar on response surface methods.
Oh.
And we met in, I remember this hotel now has been taken over by the pit. But I remember coming down that morning, and you said to me, Stu, where's your briefcase? And I said, Cuthbert, I have an envelope. I had just a paper envelope. I have my slides and everything. I'm ready to talk. And you said, Stu, a salesman always carries a hat, and a consultant always carries a briefcase. And on my honor, I've carried a briefcase in your honor ever since, whether I've needed one or not.
I'm very flattered. I hope you've learned other things, but
a few other in the meantime, I trust too. But I'd be interested, and I'm sure our audience would be interested in hearing how you got into statistics in the first place, because we know you don't have a formal degree in statistics, and yet you're a famous statistician.
in telling you how I got into statistics, I have to correct something slightly that you said. I have not been a statistician for my entire life. I became a statistician, a self-confessed statistician, at the age of 40. I was a chemical engineer and an honest man before that, and lived in Cambridge and was still studying by being a teacher. And my wife, Janet, brought home a book. She was a biochemist, a doctorate in biochemistry from Harvard, and she brought home a book by some chap named Fisher. And that book, almost by accident, I read, and it seemed to me to be an entirely natural thing to be doing, and that single volume brought me over to where I realized that I had to learn some statistics before I could apply that book. That is not a book for innocent and uneducated engineers. I did some of that, but inside of a year or two, I decided I had to get into this field somehow, and therefore christened myself not only a statistician but a consultant, and tried to find a client. A consultant without a client is a contradiction in terms. I found a client, and I shan't give its name, but at that client's workplace I found a man who leaked to me the fact that there was something going on called the A-bomb project. I made it my business to find out about that, talked my way through half a dozen guards in the Woolworth building. In those days, it's 44, and I've been 40, and got to Oak Ridge, and there one had, of course, because there was no other statistician there, even a statistician of my kind, a self-confessed one. I found ample, more than ample, overwhelming opportunity to apply what statistics I knew as fast as I could. But that happened in 44. So my career in statistics really only dates from 44 to 87. But that's skipping, of course, the first 40 years of my life, and also the second 40. I've been only telling about this little item, how I came to statistics. Well, you see now, I suppose, that every time you ask a simple question, you get a long-winded answer.
Right.
But that's something that consultants are used to, and their clients have to get used to.
Now, if you were consulting in industry in 1944, it would seem to me about the first thing you'd run into was control charting. And I wonder if you did at that...
That wasn't my first baptism. The book that one read and the only book that one could read in 1944 was Brownlee's book on industrial experimentation.
Right.
And Brownlee had an unfortunate infantile experience with control charts that made him feel that they weren't worth an awful lot. I shan't name the company at which, when he went as a consultant and asked what kind of control charts they had, he said, let me show you one of our best. The control chart had limits like this, and all the data were in here like this. A signal that anybody, including you, wouldn't know means that they've got the wrong error limits and everything else wrong. But so this had a bad effect on Brownlee, and there's this little section now in his book, which was the enlargement of that little pamphlet published by, at that time, His Majesty's Press on control charts, but very little.
Very little.
I'm not sure I'm proud to say, I'm not sure I'm ashamed to say that control charts have not been my main métier. It's helping people plan to take data and helping them analyze it that I've had some good experiences in, and also some bad ones, needless to say.
So when you were there, you found them trying simple comparative experiments without much...
that kind of thing.
Not much literacy in numerics and statistics.
Certainly. They all had read John Stuart Mill, who was the man who explained to us that the only way to find out about the effect of varying something is to hold everything constant and vary that factor. Now, of course, that became a folklore and was rigidly enforced, mostly not in the laboratory, I think, but in the lectures that scientists gave on what they had done. I do not believe that corresponds to what people do in the laboratory. They raise the pressure, they lower the temperature, they increase the concentration simultaneously. They don't even do one at a time. They do 3 or 4 or 5 at a time experiments. And if you get a better yield, that's good. And that's the way scientists who are concerned about yields work, I feel.
They draw down heavily on their prior knowledge, obviously, would be...
Yes, indeed.
Would you say they were acting in a Bayesian fashion when they did that, Cuthbert?
No, I would not. But I'm going to take a pass on my general attitude toward Bayesianism. If you give me another 5 years, I will probably be a Bayesian, but I don't know enough right now to be one. And I don't see the scientists and engineers, mostly experimental engineers, and both scientists and engineers would resent their being called scientists, I think, mostly. They're engineers, experimental engineers, lab engineers, testing engineers. They don't have a prior in any explicit sense. If you have it in an implicit sense, that's sort of a doubly subjective Bayesian. They don't even know they have a prior, and if they do, or even a bunch of priors, and if they do, by and large, they're counter to the experimental results of the experiment. If the experiment is a large one or a sensitive one, if it's a small one, it usually doesn't mean anything in the sense that you don't find, you find things by fluke or by an undetected or 3 or 4 bad values, or by as much by bad luck as by not knowing which factors to control, as by having a prior which you then modify to get a posterior. That is not what happens in my experience. My experience, I must admit, is partly controlled by my limitations. It isn't that I have a full mastery of Bayesian methods and therefore can get illicit priors from people. It is that they tell me what they think is going to happen. And at least half the time, and that's a very subjective judgment indeed, at least half and maybe 9/10 of the time, what happens is not what they thought. What does that do to the prior? Well, you can go through them, you can grind it through.
So the machinery doesn't have any meaning.
But it doesn't have any usefulness. It isn't what was. The commonest thing I hear is, well, that's what happened. Well, for goodness sake, that's not what we thought was going to happen at all. Well, what use is the prior then? It's a chastening use in the sense that it tells them that they didn't have the right idea to start with, or the right ideas, but it doesn't help with this interpreting this experiment or interpreting analyzing these data. This is my experience, more than half the time.
I was wondering that, there is a great deal of experimentation done, and very successful experimentation, which does not draw down on that class of experimental designs that you and I are most familiar with, the 2-level factorials and fractionals, and even the response surface designs or the mixed-level fractionals. These are classes of experimental designs and strategies which find wide application, and yet there's a great deal of other experimentation going on in the laboratory, apparently successful experimentation. I wonder how you can account for those successes.
I don't think I can, that would imply knowledge of a great many fields. A consultant is always working under the limitation of not being a master of the field in which he's working, of the substantive field. He cannot learn the field. It is often advised that he learn something about the field, and that's good advice, but it gives him really in a slightly enlarged vocabulary, perhaps 20 or 50 words, each technical, each in a different field, and each having the effect, if not the design, of putting the client at ease. This man knows our field. He has this vocabulary. He knows what we're doing. But that's an illusion cultivated by perhaps unconsciously by the consultant. The highest praise you can get from an engineer is for him to say, this guy talks sense. He has some of our words. He doesn't have the background, he doesn't have the detail, he doesn't know the limitations, but he knows something about our field. That's partly deceptive, partly what's called casually and misleadingly a communications problem. It's a form of disinformation that we all practice in the sense that we cannot talk about X's and Y's to a new man coming in. We have to talk about his substantive field. As Eisenhower said, we, meaning we statisticians, have to find out some of their nouns, and we put them together with our verbs and see if we get sense. And that's another long-winded explanation of what you were asking.
But when you come to you were introduced to an engineer who has a series of difficult problems he's trying to resolve, and he's been struggling with these for a long time, and you're brought into the arena, and you're introduced. They say, Mr. X, this is Cuthbert Daniel. Cuthbert Daniel's a statistician. How do you begin your communication with this person you're meeting for the first time who has all these problems?
By immediately denying that what he thinks is a statistician is what I think is a statistician. Immediately. All of his associations with that word are with Mark Twain, or with lies, damned lies and statistics, or with counting some fraction of a population, or to give the example that Jeff Watson is so fond of, he was given the job of, he wanted to go to Antarctica, and was given the job of being statistician to the New Zealand, or Australian rather, Antarctic expedition. He was given the job of counting penguins. And there's some wonderful pictures of Jeff wrestling with an emperor penguin, counting it. But none of those is what the statistician of my kind wants to do. None of those, and that's because none of those, in my judgment, is the useful thing for an engineer to have. A statistician of the kind that I think is useful is one who can, quite early on, grab enough of one problem that these engineers are concerned with so that he can suggest things to them about how to get the effects and results of the conditions under which this experiment is done in less time than they dreamed. That's active statistics. That's passive statistics is counting or taking some results from some population. Active statistics is controlling the condition under which the results are seen, under which the results are taken, rather, so that you can make some sense of them after you've taken them.
And then he replies to you, but I am, I do very small experimental programs. I'm trying to accelerate my learning capacity with very limited number of runs, and now you're promising me limited number of runs. And doesn't he get confused at this stage?
Very easily, yes. He's doing a number of runs, but he's doing them under some experimental conditions. He's holding some things constant. He's controlling his experimental conditions in some way. Would he not like, if it could be done for almost the same money or even for double the money, to know to what extent these conditions that he's holding constant also influence the outcome? Would he not? His situation is always complicated, and the man who makes it simple by saying, I only vary one factor at a time, I always use a t-test, hasn't really been talked to enough so that he takes account of the things which he's not varying.
How do you get him around to an appreciation of variance? They likely don't even know don't even have the idea in any formal way, or of noise, or...
When I went to the Woolworth building in 1945 and didn't know anything about the A-bomb beyond that it was an A-bomb, whatever that meant, and no idea. I asked about what they would do about variability that they might have. That much I knew. And was told by the dear man who ran the project, and shaking his head no, he said, no, you see, Mr. Daniel, this project hasn't been designed by ordinary design people. This project was designed by scientists, and it's not going to have any variability. Well, Manson, I wouldn't tell that story in his presence anymore because he'd be very tired of it indeed by now. Of course, it had variability, enormous variability. But I had to get in there to prove that. The plant wasn't, actually the system wasn't operating. And I did that. I must have been an awful windbag in those days. I got in somehow, and after I persuaded him that there was no need to keep bringing it up to Manson anymore, he saw it and didn't want to hear any more about that. The first paper I wrote on the internal paper in Oak Ridge the title was changed, but the title I gave it was The Diffusion Plant. That's what it was, a diffusion plant, as an aneroid barometer. It had been completely isolated from the atmosphere by billions of dollars, of course. That was the idea, to get things inside and not outside. This plant, which was enriching uranium hexafluoride, so as to get uranium-235 hexafluoride, that was supposed to be isolated. I had the bad manners to and there's no use talking about a prior here. My prior was that maybe they were wrong. I went to the airport, had to go to the airport, couldn't get over the phone. They were apparently classified, the barometer pressures for the last 6 months by the day, and plot those against the yield of the plant. They gave a high correlation. The plant was an aneroid barometer in the sense that it was not isolated completely from the atmosphere at all. The title was changed, and that thing was suitably obscured, so that we then had to get some methods for improving the isolation of the plant from the surrounding atmosphere. But you asked, what do I do about variance? I get denial. I get people who say there's so much variance. I had this in the Air Force once, so much variance that you couldn't find out anything from experiments. I always gave everything showing significance. all of these are mistakes, of course, in the sense that the variance is what is left over if you've taken out everything that's important. But that's a terribly subjective judgment. Things are left in that later on turn out to be important.
Sure.
And then you find that what you were calling the variance should have been written variance in quotes, because it was the variability at that time of the factors which you at that time had not seen fit to control. So how do you, it depends on whether you're in the Air Force or in the Oak Ridge Project or what you're in. In U.S. Steel, where a experiment, the raw material for an experiment consists of two gigantic 10,000-ton piles of coke, which were going to be applied to a plant, to a full-scale experiment. The variance in that situation is quite different from what it would be in some delicate experiment of a man in a laboratory who's going to do this experiment at 30 and at 37 degrees centigrade. The fact that they both have variance is what gives an entry to the statistician, but of course the way it's handled, both the tact and the knowledge and the background history are crucial and are crucially different.
When did you start using factorials, simple factorials in the industrial environment? Back there at Oak Ridge?
In Oak Ridge, a few of those were done. I was not influential in getting many done. There, the source of data, the biggest chemical plant in the world at its time, the source of data was so gigantic and produced so much that there a large part of my work was of the type I just called passive. It was trying to handle or summarize or do something with these data. I had one successful experience that I remember. One. Because I was the first man to handle the data, I started the statistical section there, and statistics meant record keeping. And I had, in fact, for a while, an accountant working in my group. I'm sorry to say, broke down under the strain and left. Although I'm actually glad to say it then, but I'm sorry now. Because there are 47 buildings in Oak Ridge, were at that time, each one of them having a slightly higher concentration of uranium 235 hexafluoride, I could plot, of course, and I did plot the enrichment curve for the whole plant. After plotting that for a few months, I saw that building number 43 had a flat line here. The others were doing all right. Smooth over the whole month. Well, it was the next stage that tells me that I was already a cagey enough consultant to do well. Instead of taking this directly to the management and telling them this, I went to Herman, whatever his name was, Harry, whatever his name was, and said, if some building wasn't enriching at all, what would it mean in the plant? And he said immediately, F212 is open. That's a pump. Sorry, a valve. So I called the manager of the plant and told him that F212 was open. It was in my office in 10 minutes. And it was a long way. How did you know that?
By looking at the data.
By looking at the data. As I say, and took a little perhaps too long to describe, that was my first big triumph, and I got some respect from the plant after that in passive statistics. Absolutely elementary, no t-test, no nothing. Look at the graph. Looking at a graph and having it tell something as quickly as that usually means you've taken too much data.
Often does.
But fortunately, I had taken too much. The plant produced too much all the time. So I got some attention that way. A few small experiments were done. You would hardly call them experiments. They were tests in which one raised questions with the scientist about what things he'd held constant to get his perfectly simple results. And I asked him always, what he'd not like to know, since he's held this constant, whether the same effect came out if he held it constant at some other level. That's a break-in question. Then you ask him that for some other level of some other factor. And before long, he's getting impatient. He says, yeah, but you're asking me too many questions. I can't do all the plastic experiments. I said, how many are you going to do at each of these levels? He said, 10. So
Well, an opportunity.
I I have a 2 to the 4th with 4-4 replication
Right.
in front of me right away, if I can persuade him. And it must be said, I occasionally could, not always.
All this business, we have multi-factor experimentation, and then we have this problem of the number librarian at first, the passive statistician who's asked to operate in a passive mode. Mr. Daniel, but we have all this data, and we have all these forcing factors, and we have these several responses, and in your wisdom as a statistician, can you not ferret out the associations for me? You must have run into that problem rather early.
Yes, yes. This is the big problem of analyzing data that had been collected under conditions that were partially specified because engineers are conscientious, and partly not specified because engineers have a strong sense of what's a waste of time. There are any number of books written. There are any number of first-rate minds who've thought about this problem. Not at all the first of whom was Gauss. The controversy between Gauss and Laplace that I've just been reading about in Stephen Stigler's wonderful book on the history of statistics is not the first attempt to tackle this problem. But it's one, and it's gone on, and with the development of computers, this miraculous development through the last 20 or 30 years, it's now become possible to, as we say, analyze the hell out of data with, even though a great many factors were varied, not deliberately, but just recorded. I should have said not varied. They happen to be different in this test than what they were in the last. These data, while we've by no means conquered all of the complications or gotten, as a statistician would say, an appropriate model for this set of data, there are always factors nested within factors. Always. This has been carried very far indeed now. The book Fitting Equations to Data is just one example. First written, I guess, in 71, re-edited in 79, and in my judgment, now quite out of date. Got a few good ideas.
I wouldn't call it out of date.
I would use it myself, but I'm not recommending it to many other people.
Well, if it's out of date, it's only out of date in the sense that the last several chapters have how to type out your cards and so forth and put them into the machine, which is
that stuff is out of date.
That is definitely out of date, but I wouldn't say the earlier chapters were out of date at all.
No, whether they're read there or somewhere else, they are a necessary part of the data analysts, which is what we're talking about, data analysis, of the data analyst's bag of tricks. They're not all that he needs. All of the latest developments, the newer developments of the last 4 or 5 years in diagnostics really don't show in there very much. There are a few things that we'd thought about, and those stand, and everyone agrees with them, I think. I'm answering at length again the question of what you do when there's a mass of data, a file drawer or 10 file drawers full of it. You give it this kind of treatment, you are not optimistic about what you will find. The data varies enormously in quality, of course, all the way from R-squares of 0.99 to R-squares of 0.3. R-square being the multiple correlation coefficient. Well, corrected for degrees of freedom. All of that is a laudable enterprise, and sometimes if you make a hit and produce something that was either known before or document something that was thought before, you are appropriately christened a genius or a distinguished statistician, and you go on.
A lot of good luck, though, haven't you?
Some. I would say 50% or maybe 30. 50%, somewhere in there. That's partly by selection, of course. The sample that I've dealt with is not a random sample. They bring ones to me that are hard to handle, and they bring ones to me that the book doesn't cover or something like that. But maybe 30%, or maybe 50%. It's a feeling. It's another subjective judgment. The yield, by the way, is no higher in in experimental design. If you're allowed to really influence and even control the plan of the experiment, both as to its randomization and as to the levels of the factors, you will be lucky if you have a 50% success rate, in the sense that you find something.
Yeah. That has to be said, too, incidentally.
Oh, yeah.
Because they expect, because now they've used this, these methodologies that, of course, now we've guaranteed success, and it's literally true that...
No, they're not guaranteed miracles. There's a great gain in power, there's a great gain in precision, and there's a great deal of gain in validity if the experiment was well thought out. Validity meaning the generalizability. Generalizability. I used that word in a paper somewhere, and someone wrote in the margin, some referee, no such word. So I went to the dictionary, as I always do, and he was right. The word isn't there, but I use the word still. It will be there if I keep using it, I feel. But even in properly designed experiments, yield is not high.
In these multi-factor data arrays, you've mentioned the computer and how it really broke the back of analysis, but you didn't say, and I think you deserve great credit for these contributions, much about the graphical techniques that you employed to enhance your understanding of what was going on. And really, those were of great value, Cuthbert, and I'm surprised in a sense you didn't mention them earlier. Maybe you took them for granted. They were so natural.
Well, one of them seemed obvious to me, and I didn't know that I invented it. And maybe I didn't. But the idea of plotting residuals seemed to me to be an entirely natural thing to do, which, if not new, was original. Even plotting residuals from a multiple regression, I did not know was regular practice anywhere. And I haven't taken the time to establish priority. I just did it. The other, which I was very enthusiastic about in the 50s, which goes back rather far now, doesn't it, was this idea of plotting as if they were a distribution, the 2 to the n minus 1 contrast from the 2 to the nth experiment. That seemed like a natural thing to do, because in the case I had, which by the way had 511 contrasts, I didn't see how what I could use for error, what I could call real. They stretched, of course, all the way from near 0 to 753, of course. The experiment was a giant experiment done at, I may as well say, General Foods. And it was the big cake experiment. We wanted to vary every factor that comes into the manufacture of a cake.
And how big a design was that?
That was 512 contrasts.
512.
511, yes. Contrast. It was a big experiment. There were several factors in there at 4 levels, so that you don't get.
Oh, I see.
Okay,
all right, good.
But it was a big experiment, and we had badly nested data, of course, because a bunch of cakes are put in the oven at once, and we have not nested in other respects. There were 2 kinds of flour in there. Every housewife, but not every statistician knows that there is cake flour and there is flour, ordinary flour. And every cake man knows, and General Foods has a good many of them, that cake flour is different from ordinary flour. That's a prior distribution.
I won't ask you.
Which, when the experiment was finished, turned out to be wrong. At least the experiment gave no difference whatever between all of those cakes, and even between the 2-factor interactions of the flour with the other factors that were varied. Didn't show any conditions under which cake flour was consistently or in the long run different or better than ordinary flour. Well, as soon as we showed this to the man whose name I just remember but shan't mention, he said, that's impossible. We're all cake men here. We all know that cake flour is cake flour. We got
to have cake flour to make cakes. Right?
Yes. I said, my results in quite a number of cases here, more than you have in any one experiment, don't seem to show that, but I yield to your superior knowledge. They refused to accept it. And it was a flop in 2 senses. A flop for me as a consultant because I'd come up with the wrong result. As if I had come up with the result. I never saw the cake. And it was a flop in the sense that I didn't work for that company much longer after that, because the man that can produce results like that has got something wrong. 4 years later, I happened to read in the Times that General Foods had sold its cake flour mill. It took them that long to come to the conclusion that cake flour was no advantage. They weren't buying cake flour from Canada. They were just they saw that they finally saw it. But my powers of persuasion did not suffice 4 years back from that to persuade anybody. Statisticians who were there, or managers, or cakemen, that for the particular scores we were getting, there was no difference at all. So an enormous power compared to what had been done earlier between the cakes, between the effects of cake flour and ordinary flour.
When did you kick up the idea of doing half-normal plotting, though? That was,
Right
you say, right at that time.
At that time, when one has a 511 contrast, one wonders what to do with them.
But you didn't plot them with respect to sign. I mean, you intentionally truncated the sign and put on.
If you'd like to take a minute, I can tell you. Since a lot of those were random, I thought, well, the sign isn't what's important if they're roughly balanced in sign. So they're really little ranges. The contrasts are ranges if you take the sign off. So I didn't know the distribution of the range, but Hall did in his book, in his table, for instance.
That wonderful set of tables, that wonderful book.
Oh, yes.
Tremendous. Still one of my favorite books.
But the distribution of the range is in there. I plotted my range on the same thing, and of the 511, 500 lay on the graph, so to speak. Now, I was plotting ranges, and of course the plot of the range on normal paper, on normal grid, is not straight, it's slightly controlled. It was Alan Birnbaum who saw immediately that if I plotted these on half normal paper, and the name should come from him, and the insight was his, and I took the paper and cut half of it off and put the 1 minus 2p instead of p on the plot, and got, for those data, beautiful straight lines through the great mass, the tremendous majority of the data points. Each piece of data now, I shouldn't have said data, contrast points, absolute radius of contrast. That seemed to me to be a tremendous step forward. And I got, as the paper that I published in 59 showed, examples from 10, 20 other fields, and plotted and showed that this happened not just cake flours, but in everywhere, so to speak, if you had enough contrast.
And yet I've heard you say more recently that you are now doing full normal plots as opposed to half normal. Would you do that if you ran I ran a 32-run fractional of some sort and wanted to analyze my contrast? Would you recommend?
Let me think. In the book on applications of statistics to industrial experiments, I don't give any half-normal plots. Now, there must have been a reason for that. The reason was that I found that in taking off the signs and in reordering these, I was losing more information than was in the original contrast. If you look at the contrast that you get from the standard Yeats calculation, they have patterns in them, and you can see them all. Those patterns are lost if you take the signs off and juggle these things.
Yes.
So that in going from the ordered statistics that you get from the Yeats calculation to the order statistics which you needed with the plotting, you lose information. And that information
that's your point.
That's the point.
That's the point.
Yes. And that I did not want to lose. So that again and again, especially in big experiments where you'd feel most secure in plotting these, there's also more evidence of order. And that gets lost if you take what are called order statistics, which of course are always ordered by magnitude.
And yet the whole idea I found of half-normal plotting, which was so very, very good, was that it only gave 1 degree of freedom to the plotter. In other words, that blooming line had to pivot through the origin. Its failure to pivot to the origin was a sign of one thing. And
I may be swinging the other way now. And by the way, when it doesn't go through the origin, that tells you something very important.
It's still a valuable diagnostic tool.
I suppose so. And maybe I'll be in, if there's another edition of that book, maybe I'll put it back in. One ought to have some variance in these matters. And it's not a clear-cut case. I just felt when I wrote that, when I was writing that book, that it was it would keep interest up if I took them out, didn't mention them, and explained their hazards that way, because I've made mistakes with them too. Well, mistakes can't be ruled out by any method, of course. When they're revealing, and when not. As Gertrude Stein said about Ezra Pound, you remember, and I have to get the words right. She said, he was a village explainer. All right if you were a village, but if not, not. I didn't misspeak. She said if you were a village, not if you were a village. And so with this thing, it has to be viewed, it doesn't do any good to say it has to be used with caution. Everything has to be used with caution. One has to know what cautions to take. I wouldn't forbid anybody to make a half-normal plot. And I wouldn't take it as a revelation from the Almighty. It came out very clear.
Very, very clear. But you know, in many ways, you were first with respect to the concern over the residuals, finding the additional clues in the data that fell in the residuals, and these graphical techniques for exercising the residuals so they would speak up, or not the residuals, the contrast, the estimates that we got. Those are remarkably important contributions. You must be.
Well, I've seen them used quite a bit now, and I don't follow and make sure that I'm not in charge of making sure that everyone uses them in a way that I think is proper. I just mean that they were natural to me, and neither of them was a result of deep ratiocination or of a long struggle. They seemed obvious to me, just as statistics did when I came into it. And by the way, it didn't after I got into it, I must admit. But Fish's approach seemed to me to have something natural. I've tried to go back and make my peace with the one-at-a-time statistician by writing a paper on one-at-a-time experiment. But that has, so far as I can make out, produced no response. None. I don't keep that's a test of very low power. I don't keep an eye on all the publications to see if anybody's talking about one-at-a-time experiments. I think I would hear, though, somebody thought it was good or thought it was bad. I would have thought at some time somebody would have said that to me, or that would have reached me. It hasn't. A terrible disappointment to me, because I thought that I was making the right, the Christian appropriate response to the one-at-a-time statistician when I thought I would show him how to do those better. Rather than showing him, as we do now, impatiently, no, you're doing it all wrong, you should do it this way. So one should start with his experiments and broaden his experience from them. I thought that was both clever and constructive. No response.
No response.
I don't say that with quite the bitterness that it may sound to have, but...
If you ran into a physicist or a very theoretical chemist or something like that, and you wanted to quickly persuade them to the value of your strategies, to the value of using statistics, how would you do that? What would you say to them?
I first force him to describe his experimental situation in as much detail as he thought I could understand.
Well, suppose you met him at a cocktail party, and he said, I introduce you to Dr. XYZ, a famous physicist.
I'd say, let's have another.
And then he'd turn to you and say, and what is it that you do, sir? And then you'd say, I'm a statistician. And then
I wouldn't say that.
Oh, you wouldn't say that. That's why I'm wondering how you react. Yes.
Because I know his
turn off the conversation. Yeah.
That's a way of antagonizing a man, so to say I'm a statistician. I try to help, and have had some success in helping experimental people do their experimental work. And they say, well, what do you know about their experimental work? I say, well, I know a few things. I know that 1 and 1 is 2 under favorable conditions. And I know a little mathematics. And some of these things work over quite a wide area, not everywhere. I have a big smile. I would conciliate him and not deliberately antagonize him by saying I'm a statistician. That's unfortunate, but unmovable at the moment, it seems to me. We can talk about educating people not to think that way about statisticians, but as you know,
it's cultural lag.
It's one of those. If I say I'm not a communist, but I was a Trotskyist, I've cluttered the atmosphere with 50 different things because that man neither knows what I meant by communist nor what I meant by Trotskyist. And by the way, I wouldn't say that, but I'm giving an example of how words, in a case that I've run into, how words determine the atmosphere for either permanently, the man walks away from you, or temporarily, and you then have to plaster over and fix up the mess that you've made.
But this is a curious man, and he recognizes you as an intelligent being, so he presses you further, and he wants to know what it is that you do.
Yes, I have a favorable example comes to mind. We're riding in the helicopter from the Boston airport to a little company on Route 128. The man asked me what I do. Turns out he's the president of a company. I'd tell him, oh, I'm just a man who shows people who want to weigh, have two things to weigh, and want to know a way to weigh them that's twice as good as weighing each one separately. He says, you what? Well, I've got him now. I now have him. If I don't talk too much for the next sentence, I now have him. This man, Frank Lindsay of ITEC, was one of those rare presidents who knew what his company was doing in great detail. Not a manager in the bad sense, but a manager in the best sense. As soon as I got 12 people assembled in a room at ITEC, Frank introduced me. He said, Cuthbert, tell them about the two weights. So I was on my way. The best way to introduce statistics is not by something complicated where you've conquered a mass of data. It's by taking the simplest possible example and using it to show an imaginative man what the minimal amount that you can do, which is 100%, and what it will be in other cases where the situation is more complicated. This situation does not get worse as you go to more complicated situations. It gets better. At least precision-wise and validity-wise. You put in more factors. Does that answer your question?
Yeah, I wondered. Well, it's a good question. I've never had never had anyone challenge me that way, but I suspect that would be a good trick.
I had the experience once in my life of finding myself at a table at a picnic between Fritz Lippmann, a Nobelist, 1953, discovered coenzyme A, but who happened to be a neighbor of mine in the country, and Severo Ochoa, a Nobelist from 1952, in a neighboring part. They're good friends, and I, by accident of fate, got seated between them. I should tell you that Fritz had already told me that he hated statistics. So I had told him, in that case, we'll never talk about it again. You don't press a thing like this on Fritz Lippmann. He doesn't want it. So I told the same story, talking fast. Severo Ochoa is a very tall man and looks down at me like this and said, Mr. Daniel, exactly what do you do? Because I'd been kidding around. And I told him in one sentence fast, I shan't repeat it, what I do with two weights. He said, you what? And I started to tell him how to do it. He said, don't tell me how to do it. And in about 25 seconds, Ochoa went through. He said, you could weigh them both together. Yeah, and then, oh, you could put one on the other side. He saw it. Then he turns to me as if I had told him something and said, but that's very good. That's the kind of man one likes to meet.
Yes.
On the other side of me is Fritz Lippmann.
And he says,
what does he want to know more precisely for? I'm just giving an example of two weights of another kind, which you can't. You cannot win them all. In fact, if you win half of them under those circumstances, you're extraordinarily lucky. But that piece, that doesn't mean that Ochoa became a disciple of this kind of experiment. He was already retired when this happened.
Speaking of, in a sense, famous people, you mentioned Alan Birnbaum a little earlier, but I know you did a great deal of work. You used to collaborate with Henry Chaffee. And maybe you'd like to reflect a little bit about your associations with...
My experience with Henry Chaffee was a wonderful one. We met at Princeton in 1947. And Henry saw that I was a man in need of help, but also a man who could take it. And he did without remission, steadily, from then until the time he died. He was my mentor, my conscience when I didn't know enough to be conscientious. That was the real point. And my educator. It was a marvelous experience for me because, as you know, and as many know, and it was looked like a man who worked in an entirely different field. He was a theoretical statistician who was actually theoretical because of shyness. He was not able to sit in a room and have other people talk to him. He couldn't keep a straight face under those conditions. He couldn't believe that what he had to say would really help them, even though he knew the whole field. And his book on the analysis of variance, of course, it's a theoretical book, and yet it's full of practical experience, especially in the later chapters, in a practical sense. Well, a lot of that Henry found was worthwhile talking about from talking to me, because he found I was a standard ignoramus who could be depended on to say every Philistine suggestion in the book. And not in the book, I mean, they got to be in the book as he wrote it. as a consequence. So Henry was priceless for me, and I was of some interest to him. I don't know if you remember Henry's face.
Oh, yes. I used to go swimming with Henry Chaffee, yes. Broken nose. And,
yes. He was a tough-looking man.
Tough-looking guy, but he was a gentle person, no doubt of that.
I remember walking across the Manhattan, Kansas
campus. This is a good one for you, man.
Yes, I'm sorry about that. And realizing that I need now a haircut. And saying, Henry, let's go to the barber shop. But we went down, Henry, he said, sure. He sat in a chair and read a newspaper while I got my haircut. In the middle of the haircut, the barber said to me, hey, who's that guy sitting over there? I said, that's my bodyguard. Henry heard me say this, and immediately the paper and the whole stance changed. He's a born actor. Mm-hmm. And the barber looked at me and said, wow. But we had any number of pleasant experiences, mm-hmm. some in statistics and some not. And although I could never get him to put in simple enough examples in the book, he was never afraid to take the examples I did give him and treat them like the man he was in a serious way, thoroughly and mercilessly. Mm-hmm. And that way he was priceless.
Another great gentleman that you collaborated with, Frank Wilcoxon.
Frank was another type, but a lovable, wonderful man. Right. He was a chemist until quite late in his life, as is true for different people at different times in their life. After all, wasn't Newton a chemist? Wasn't Turkey a chemist? Mm-hmm. Mm-hmm. Something about chemistry that prepares us, some people slowly and some fast, for a career in statistics. Frank was so sweet-tempered and so good-natured that when he showed me one of his examples and one of his ideas, a little idea actually, it looked like at first until I looked at it more, there is one order of doing a 2 cube, 3 factors each of 211, which is immune to either linear or quadratic trend. Mm-hmm. 1 out of the 8 standard arrangement. I said, that's perfectly wonderful. We must write a paper on it. He said, no, you write it. That isn't what happened. We both wrote it. And it came out to be a very interesting thing, especially when you get to bigger things in the 2 cube, where there are a good many more things you can do, and where, although one principle is violated, the principle of randomization, so far as order is concerned, is violated. Not in other matters. You can randomize choice of substrate.
Other ways of getting in.
But you can't randomize the order. That turned out to be a medium good idea. I have very few examples by now. That paper was written, I believe, in '68. Mm-hmm. These things, one has to write them under the illusion, I almost said, that they're going to be bound to be very useful. Usually they turn out not to be very useful, but they turn out to be a little useful to somebody. What were you going to say?
No, I was going to say that's a useful idea, but you're quite right. You don't, even in my experience, I don't see it very often. I don't run into it very often.
No.
They
none of these. One cherishes them when one finds even a hint of it.
No.
But one spends a year on a paper, at least I do, or more, 5 on the half-normal plot, and then finds that it's 20 years later, or in the case of the half-normal plot, 30 years later, it's being used more or less in some places. One can't give it anymore. Tony Atkinson thinks it's great, and other people don't. So, but there's no point in conducting a poll about that. If somebody finds it useful, they will use it. Frank, to get back to Frank, he had such an habitual good nature and was such a sweet man that I wondered how far that went. And I found out as I worked with him, he also had, how to put it, he felt after a certain amount of good nature, like 3 months, he had to pick a fight. And about every 3 months, Frank would pick some fight, often a meaningless one, statistical quarrel with him. It was as if he'd gotten tired.
I saw this I never saw
It was
this.
as if he got tired of being sweet.
Good guy. Uh-huh.
And there was another man under there that had to make some difference. And as I remember the cases, they were artificial. It was as if he looked for a quarrel. And I said to him after the second one of these, I believe, Frank, you're looking for a fight with me, and it won't work because you can't fight with me. You're one of the men I cannot fight with. And it didn't. And he was maybe then or maybe in the next week, he would brighten up and we'd get back onto a wonderful basis again. But and I take some credit for that because I saw through his need for this quarrel, but I wasn't going to satisfy that need because actually, as you know, I could be very unpleasant if I'm fighting, and so I never had a quarrel with friends because I never accepted it.
And of course, another gentleman you've worked long and hard with is Fred Wood. And,
oh yes, Fred is again a different case. Fred was a chemical engineer in charge of a section at American Oil who saw some good in what I was telling American Oil when I went out there first. And we were able to collaborate for many, many years. That must have been 15 years before we wrote the book. Mm-hmm. Fred and I have a wonderfully complementary relation in the sense that the things I don't know anything about or haven't the patience or ability for, Fred has. And I wouldn't say vice versa. Mm-hmm. But so that he was a wonderful augmenter of what I knew and showed the practicability of one thing after another. So that by the end of my time, I was just ignoring what could be done by computer and just saying, this is what I want. And it was often something that looked impossible at first stage, but Fred would finally say, see how to do it. This happened over and over again in the writing of that book. The fact that now we look at 80 variable equations for 10 billion alternatives is entirely due to Fred, not to me.
You always tipped your hat very sweepingly to John Gorman, too. And,
Gorman was in that same class.
Yes.
He was just under Fred and implemented a great deal of what Fred suggested. Those were two men who went somewhat beyond the normal limits of cooperation.
and how about Colin Mallows?
Mallows has been an early, I started to say discoverer of mine, I mean of me. He's been one of the people that kept me going because if you drop a big paper out and you expect a tremendous bang or at least splash and nothing happens, that's very discouraging. Mallows has a very sensitive ear and would notice that and would call me and give me the kind of support I needed. Since I am obviously mostly a loner, I need support. And in statistics, and Mallows has been consistently wonderful in giving me that.
How about Frank Hampel?
Well, you know about my relation with Frank. Walking across the Berkeley campus, where for obvious reasons I'd been invited to give a course, a bearded giant comes up to me and says, you know, I was going to leave statistics, but you've changed my mind. That was Frank Hampel. Well, that was a long time. That was not very long ago. That must have been 68. So Frank and I became fast friends. And we still see him whenever he's in the country. He's a wonderful bird watcher, so he's always glad to come to my country.
If you were going to advise young folks who are intrigued with statistics, either as undergraduate or as graduate students, and you were going to recommend things for them to read, what would you, have you any favorites, particular favorites that you have in mind? Make them wise. If you could make people wise.
I'm afraid I'm beyond that stage. I'm too far away from the young people. Their attitude toward me is largely determined by my extreme age and my extreme concision in speaking, and not by what I have to say. I've noticed this again and again. People are sizing me up more than they're breaking over my content, so that I'm not optimistic about talking to very young people. Of course, 7-year-olds I can talk to because I'm quite good with string figures, and you can talk to 7-year-olds that way. But young people just out of college, I feel, are in a missing gap. I'm sorry to say. I tend to project the punk clothes and the messy face and the as if these were indicative of their professional future, which of course they're not. But I tend to. So that I'm a reactionary in the sense that I hadn't expected to hear myself say so, but I am. And therefore I tend not to be in sympathy. If somebody comes to me and says he's heard a lot about me, I would have to ask him first where. I'm a poor understander of my own work. I'm a poor understander of the younger generation. I have limitations, and it's time I started admitting them, not boasting about them, but admitting them. When one is young, one doesn't admit them at all, of course. But that's not a pretense I'm permitted to continue.
How much teaching have you done, Cuthbert? I mean, I can recall only when I first came up to the New York area after graduating, I taught over at Rutgers, and I can recall talking to you about lecturing to a class of students, and you gave me actually a set of your homework assignments. You just gave me 5 or 6 examples. You happen to have them ready or on a piece of typewritten paper, just slipped them to me, and I can recall slipping them to the students and seeing what their reactions were. I was just wondering how often do you teach in that sense of the word? I mean, you teach as a consultant, but how often do you stand in front of a class and try to exposit the subject?
Not very much lately, I'm afraid. I think the last formal classes I taught were probably either at Berkeley in '68 or were at IBM 3 or 4 years ago. I put myself in the position of a teacher often, in the sense that I think to myself, how would I teach that?
Do you recall that Gordon conference that you and I were at? I was a very young man, just coming out with the response surface stuff, and you gave that lecture on the various shapes of the quadratic surfaces and the Mexican sombrero.
Oh, yes.
You recall that?
Yes.
I remember that vividly. That was so good. That was good teaching. That was expressive.
Well, it was one of those elementary things and the bent rain spout.
That's right.
That's the linear biquadratic interaction. One tries to visualize these things, and that isn't automatically successful, but in those little simple cases, they do have shapes. The linear biquadratic is very implausible, and anybody who's looked at a gutter that has been concave at one end and gradually goes over to being convex at the same end will see that isn't something that's awfully likely to happen. On the other hand, the sombrero is entirely conceivable. That's a dimple in a surface.
Oh, it's remarkable how geometric you really are when you get right down to it. How about your appreciation of experimental designs? I recall that JASA paper where you were one of the first people to try to show the associations between the interactions and the confounding patterns using line graphs and so on.
Yes. But those are the automatic ways that a person who's mathematically limited tries to make sense out of what's happening. And that's my situation. Those are not my... Daniel, as a mathematician, simplifying things for the sake of his ignorant audience. Those are records of my efforts to understand what the hell is going on.
In the first place, right?
Yeah, in the first place.
Yeah.
I have a continuous record of failure in mathematics that I probably should put in the record. I went to MIT as a chemical engineer for a very simple reason. My mother said, "Buddy, you're going to MIT and become a chemical engineer." She'd read that in some magazine, and I said, "Yes, Mother," and went, and was be a chemical engineer, until I discovered the mathematics department there, which had some courses in it that I wanted to take, and so I took all of the courses in that department. The math department in MIT when I was there, was I almost said derisory. It did have one man in it, but I couldn't understand him. That was Robert Wiener. The rest of the people I shan't mention. They are rightfully forgotten, I believe. And I rightfully forgot most of what I tried to learn from them. I didn't get it, they didn't teach it, and there was a non-communication, a zero experiment. I went to Berlin because I wanted to study mathematics again, and took courses with some distinguished people like Bach and a chap named John von Neumann and others whose names I don't seem to recall. Again, it was too hard for me. I'm not a mathematician, and I was slow to realize that. I'm not gifted in it, and not going to learn it. Some resistance, or some limitation, but it's there, and I've had to learn to live with it, and I don't learn to live with it by calling myself a mathematical statistician. I learn to live with it, this type of thing you just mentioned. If this thing can be simply pictured, the picture doesn't lose anything, and that's the way both for me to learn and teach it.
These, in your consulting experience, I recall, of course, as I said, my first consulting assignment was a consequence of your getting me to lecture to
U.S. Steel.
U.S. Steel. But you've been to the big steel industries and pharmaceutical houses. You once told a lovely story about, Brownlee. You were at, he had worked, I think, for J&J, if I'm correct about this. You were at a laboratory one day and you were standing talking to these guys. And you said, I counted out of the corner of my eye that they had, it's either 16 or 8 claves. You count these 8 claves. Aha! What a wonderful opportunity to do factorial designs. And then somebody said, well, we were persuaded to put those claves in because of
Brownlee.
Of Brownlee, right, way back there. It was really
that's a story that I don't remember.
Well,
on the other hand, Brownlee was a decisive influence in getting me into statistics, partly because the book was in 1946
great.
the only book.
Only book.
Yes, there was a book by Freeman. There was a book by Reitz, but those are rudimentary compared to the detail and the complexity of the things that Brownlee was going to tackle. I haven't. I don't think I ought to tell any stories about Brownlee because he's become a reactionary and I'm still a progressive, and so the stories tend to come out on derogatory.
I don't know whether Professor Brownlee has been part of the distinguished lecture series or not. It would be an interesting thing to suggest to the ASA.
I wouldn't like
bring him on, right?
Oh, I don't think he will.
I don't think he would. What do you think of all this work in time-dependent data? The great concern of a lot of practicing statisticians in the engineering environment is the fact that the data are sequentially recorded, or that I'm running a continuous process, and I have to sort of place my experimental designs into that environment. I don't run claves or do batch experiments. I must run on a continuum.
I do that if this interview went on too long, you'd start exposing too many of my fields of ignorance. And that's happening now. I don't really know, in addition to not knowing anything.
Now, once again, you were prescient here, because the work that you did with Frank Wilcoxon was...
Yeah, but that has very severe assumptions.
Yeah.
That assumes that just the opposite of time sequence, that assumes that there is no autocorrelation in the structure at all. That the experiments, even though done in sequence, do not show any correlation of the errors.
Mm-hmm.
So,
it's a deterministic trend that you're trying to protect against, right?
And it really is it's an attempt to fight off time series analysis by making the assumptions that don't fit it, and then solving that problem. And that's not fair from the point of view of a time sequentialist. Of course, by far the largest part of the experiments that are done are time sequential, and one does not, as Frank Hempel has been very clever in showing, does not allow for that at all, and assumes things are independent, which are not independent. He often finds the degrees of freedom are a half or a fifth.
Mm-hmm. What they think they are.
What they think they are, just for this reason.
Right.
One way to put it. So, time sequences, no. Bayesian statistics, no.
How about three-level fractionals? Have you anything to say about? There's the two-level fractional factorial has been reasonably well explored. I suspect there are sideband things we could still consider with respect to two-level factorial, but you run into an engineer and it's amazing how often they're hung on 3 levels.
It's because they want to get it, in the crudest way to put it is they want to get some indication of curvature.
Yes, right. As though that were the most important.
I worked out, and it took me 6 months to work it out, the feasible sequence of 27 runs for the 3 cube, which are bearing one factor at a time, and which reveal more information as each factor comes in.
As each factor comes in. That's adding the factors you come down.
Yes.
I've seen that someplace.
It's in the paper, the Fisher Memorial Lecture, which was received with resounding silence on one-at-a-time experiment.
Yes.
74. That again, one has to wait 10 or 20 years according to Bill Cochran.
Where it filters.
I don't really have 20 years. So I'm hoping for some luck in connection with those. Somebody will notice that and say, here, some funny guy in some other funny field has got this diagram. Then I will know that I have not thrown this in the ocean, that somebody's picked it up on dry land and that it's still there. At the moment, I do not know. This is the gamble one takes when one writes papers. If one is not as brilliant as Pesci Diaconus, then one has to wait and see what happens to the few little things you do.
I know one question I'd like to ask you, and that is, suppose my response is really multivariate. I mean, I am following a five-dimensional response or something of that sort. I may or may not have run a factorial design, but let's say we planned a design to follow a principal response, but concomitantly I have 4 or 5 other responses which in a sense are correlated with one another. You can run into these problems obviously in the pharmaceutical, biological arenas, if not in industrial areas as well. Do you have any attack on that? Do you have any approach to that class of problem?
My approach is to look for a good consultant to give to that client.
That's unfair, Cuthbert.
I'm not defeated. I'm just in the nick of time learning my limitations. That's all. I remember my mother saying to one of her friends, the Daniels mature very slowly, if at all. And that's still going on. And at my age, I'm neither looking for clients and I have to wait very patiently before I take on a problem. I have a problem with one client, and it's an excellent one, and I'm working on it. It doesn't come up here. It's not quite the thing you give. It's the question of experiments with carryover. And that I've got, at least for the limited situation in which this client finds itself, fairly well covered. But you ask me about another now, I have to plead fatigue, or ignorance, or lack of time, or hunger at this particular moment.
Well, it's
Thank you for waiting so long before you asked me a completely unanswerable question. I've had a long history, obviously, although it doesn't go as long as it might appear. I have only been in the field half my life, but it's a wonderful field, and I got the feeling again 2 nights ago reading in the journal what's it called, Statistical Science. The long interview with Pesci Diaconus, perfectly wonderful man, in so many things that he doesn't even know how many books he's writing, or what papers he's working on. But on each of them, calling up instantly when he's asked, the wealth of thoughts that I had not had or would never have, as close to a first-rater as we can get nowadays, it seems to me. So the field is very active indeed, but the field is not me. I'm tottering around, getting out of the field. Diaconus is plowing ahead, getting into it in 8 dimensions.
Before we close this, there's one other question I'd like to pose to you. That is, if you hear Professor Deming speak on statistics and statisticians and education and statistics, he goes around, he declares that there's a diminution of interest. There's that statistics as a profession is in its decline. He quotes, for example, the lessening number of schools that are teaching statistics, and he sort of feels that having fewer and fewer graduate students. I'm not sure that this enumeration is correct, but it's his sense that as a field, as a philosophy, we are not growing. We are stagnating. If anything, we are in a state of decline. I don't agree with Professor
No.
Deming, but I'd like to get your reaction on that.
It's just the same as yours, except more parenterally. No, I don't agree with that. And I wouldn't want to tackle Ed, who's been a friend of many years, one-sidedly when he's not here. It's my impression that he uses one device after another, most of them deliberately, to provoke his audience.
Yes.
And that's what he's doing here, in my opinion. I'm not giving a complete analysis, but that's, I believe, is a very large component
That's very helpful, actually.
of his. He's now in an unreachable position. You can't edit Deming out. You can't referee his papers out because he's not going to write them. He's going to go directly to the consumer. Sell the same paper 100 times. That seems to be a better way. A little like Linus Pauling, who's escaped the referee process by running his own books without any referee. And that's all right for Ed, I think. That's not going to do unlimited harm. And he has limited influence. But Ed is very much so, even more than I. He's got a desperation of message in his last years that I have not. I'm cooling off. Ed is heating up. We're going to go out through different doors.